Section 7.1, now we're going to talk about natural deduction. You're going to like natural deduction. It's another way of finding out if an argument is valid. That's simpler. It's a little bit more enlightening. You're actually going to like these because instead of truth tables, we're going to be using rules of inference. And this is where your book's going to come in handy. Here's your book. You have a flap in the back of your book, everybody. And they have it in a way where when you pull it out, no matter what page you're working on, you can find the lists here of rules of implication, rules of replacement. Okay? So right here, we're going to be dealing with the first 4 rules of implication. Okay? And this flap is kind of handy as opposed to flipping through the book. And the first 4, they're right here. Modus ponens, which you're familiar with throughout the course. I've mentioned it several times. If P then Q, P therefore Q. You know, if it's raining outside, the streets are wet. It's raining outside, therefore the streets are wet. Modus tollens, and you're familiar with that from section 6.6, actually the last video I did. Hypothetical syllogism and disjunctive syllogism. These are the first 4 rules of implication that we're going to work with, and we're just going to only use 4 for right now, and I will use those 4 to show you how to see if a proof is or an argument is valid or not. We're trying to derive a particular conclusion, and if you can do so using the rules of inference, and right now we're just going to work with 4, you know the argument's valid. Okay? So, from these 4 rules, and I'm just reading from the handout here, the conclusion of many simple arguments can be derived. Since each rule is a valid argument form unto itself, any conclusion derived from their correct use results in a valid argument. And this will all start making sense when I start doing some examples. Let me keep reading here though. How does a proof in natural deduction work? A proof in natural deduction consists of a sequence of propositions, each of which is either a premise or is a new premise derived from the preceding propositions, by application of a rule of inference, and the last of which is the conclusion of the original argument. Okay? Keep that in mind, what I just read. And when I start doing the examples, this will all come together. But before that, I do an example here. I want to talk about some preliminaries here. So let's say we had this. If, okay, there we go. If P, then Q, right? P, okay. If I was going to say, can we derive P? Let's say we want to know if we can derive Q, okay? And we'll call this premise 1 and premise 2 right here. And this slash, the way this works is whatever you're trying to derive or whatever your conclusion is, you do a slash like this and a Q. We're not going to be doing the single slash for premises and double slash, okay? Those are gone for natural deduction. Here, you write out the premises of an argument, and on the last premise you go over, you draw a slash, and you draw the conclusion. So this here would be telling us that we're trying to derive Q from these premises. We're seeing if we can do that. And if we can, the argument is valid. Okay. So if we had something like this, if P then Q, P, and we were trying to derive Q, you all already know, well, if P then Q, if we use this with P, because of modus ponens, we could get Q. So let's say from these 2 lines, premise 1 and premise 2, you all can easily see how we could get Q because we use these 2 premises with modus ponens. You remember modus ponens? MP is this. If P then Q, P therefore Q. And I don't know if before you all realized the significance of this, but you remember in all my examples, if I would do something like if P then Q, P, we'd go therefore Q. When we wrote that Q down, we added another line. When you say this argument, we can conclude this, what you concluded, you added. So this part here, everybody, was knowledge possessed, right? We already had this. But when we from this added this line, we added something that is very significant. Okay, I'm going to put an exclamation mark there. We added. So this is knowledge gained. And I don't know if you thought about that, but every time you say therefore this, we added something. So that's what natural deduction is about a lot of times. We're trying to get Q. And really a lot of these is how do we get Q all by itself? How do we isolate it? We see Q up there, and that's premise 1, and premise 2 is right here, and we can tell that if we use premise 1 with premise 2, we get Q. Now when you write that down, you've already seen how you can do that. I've used the first two premises, the only two, and I've used modus ponens, right? But imagine someone saying to you, well, I would just like you to tell me what gives you the right to write down Q. Just imagine someone just putting their hands on their hip and saying, what right do you have to write down Q? And you could say, well, I am justified. I will justify myself in writing down Q because I used lines 1. Look what I'm drawing now. This is called the justification. I use lines 1 and line 1, and line 2 with the rule of implication or rule of inference, modus ponens. And that's why I got Q. Okay? This is what natural deduction is about. Now this very simple one, I'm just trying to show you. You see how you could see that. Now what if I did this, everybody? I'm going to erase. I'll erase 3 right here. I'm going to erase this here. And let's say I add some other lines in here. Okay, now watch. I'm going to do this. I'm going to let me erase that too. I'm going to erase that, and I'm just going to put the P down here. So we have the same 2 lines, right? So down here I'm going to put P. And how about for premise 2 I have either H or D. And line 3, I have if G, then K, let's say. And on line 4, I have P. And then we have over here the slash and a Q. Okay? So right here, I've just added a little bit more in here. But let's say you're trying to get Q. Can't you see if you're trying to get Q? You still, when you're looking at this, you go, well, I'm going to use line 1 and line 4. These lines here are irrelevant. So a lot of times with natural deduction, you may have other lines that you need later on. Maybe there'll be a line you'll never use. But just because I put more lines in here, did this really make this problem any different? No. If P, then Q. If P, therefore Q. So we could still write down, it would be line 5 now. Line 5 would be Q, and if someone said, well, just how did you get that? You say, well, I used line 1 in this example, and line 4, and I used modus ponens. And if you wrote line 1 and line 4 off, you'd just get this right here, wouldn't you? Okay? So just because other lines have been added in, it doesn't need to make it more complicated. Okay? Now, let me do something here. Let's say we have, let me erase up here just to, okay, let me go and erase this. We'll start over. Okay, let's say we have line, well, 1, 2 will have if P then Q, okay? Line 3 will have something, and line 4 is J, okay? And we're trying to get Q. And let's say premise 1 is either K or P, and 3 is not K, okay? This will kind of be a two-step thing. You remember before the example, you could see it was right there. There were two premises. If P then Q, P, I did it first. You got that real easy. Duh, that's how you get a Q. Then I slipped in a couple lines there, right? And that didn't fool you guys. You still just saw the two that you needed, even though I interspersed some others. Here, we're going to go backwards. In a sense, you're going backwards, trying to figure out how you can get Q. Here, I've added a little twist. Okay, how do we get Q? And the first thing you do is you find what you are looking to conclude already in one of the premises. And we see Q right here. The trick is, how do you get Q by itself? And if you use modus ponens, one of the strategies is, look up here. If P, then Q. The way to get Q by itself, a consequent, this is a consequent of this conditional. A way to get a consequent of a conditional all by itself is to use modus ponens, right? If P, then Q. If you have P again, you can get Q all by itself. So we want to get Q, and there it is. How do we get Q by itself? We know if we can have a P on a separate line, we can get Q in another step all by itself through modus ponens, right? So, but we don't have P all by itself. But notice, so before P was right there, right? The two premises you needed were right there. There was P, no brainer, easy, you're done. Here, to get a Q by itself, which is what we're trying to conclude, we need a P by itself. But P is not by itself yet. But if you look, is there a way to get P by itself first? Because we need to get P by itself first and then use the modus ponens. So we're going back a second step in a sense. And if you look at lines 1 and 3, we could get P. And if this helps, go ahead and draw. Let's say you had line 1, either K or P, and you have not K. Through disjunctive syllogism, these two knock off and you could get your P. So, let's do this. We're going to get P from lines 1 and 3. So remember, someone says, well, what gives you the right to do that? And you say, well, I can justify myself from lines 1 and 3, disjunctive syllogism. Okay? Then, now we have our P. And every time you do a natural deduction, derive a proof like this, we were bringing the P down for a reason. We were not wasting time, right? So we brought the P down by using 1 and 3 with DS because we need it. Now we can use P with line 2, with premise 2, right? Okay? So if we have premise 2 and premise 5, if we wrote them off to the side, if P then Q, P, see there's the if P then Q, there's the P, what does that give us? Q. So we can write Q down, and if someone says, what right did you have to do that? You go, well, I use lines 2 and line 5. That's line 5 right there. This is line 2. 2 and 5, modus ponens. Okay, everybody, that's what's involved. Now, in your book, they are going to use, you're going to have 7.1, 7.2, 7.3, and 7.4, and each chapter they'll keep using more and more rules of inference. We're just starting with 4. And here's one thing I want to tell you. In exercise 7.1, exercise 7.2, exercise 7.3, exercise 7.4, you're going to have section 1, section 2, and then section 3. Section 3 is going to be stuff like this, where you're given a list of premises, a slash, and what you're supposed to derive, the conclusion, and you've got to figure out a strategy by working backwards. 1 and 2, these sections here teach you little steps. They're designed to prepare you to do the part where you have to figure out the strategy. So section 1, I believe, is going to be little problems that helps you do the little steps individually. Like you're given a list of premises, like one, you're given 2 or 3 premises, sometimes 4. Which 2 lines could you use to get the conclusion? Just to get you to practice how you use these rules of inference. And section 2, they will have a missing premise. And what do you have to have written in there for a missing premise? What premise do you have to add in? And then when you add in, it's enough to give you the conclusion. So, you know, these are little steps, and don't get offended. 1 and 2 are baby steps. The author put them in there to help you have the light bulb turn on. And once the light bulb turns on, everybody, okay, there's your little light bulb, then you're able to start doing these where you work on strategy. Okay, so here's what I'll do. I'm going to, let's add another page here, right there, and I'm going to give you some examples of how these little baby steps work. Okay, so let me go to 7.1 here. Here's 7.1, and I'll go to Roman section 1. Here's what I mean by some of these baby steps, okay? So we'll go, all right, so if I'm just doing a start problem, we have if G, then F, and 2 is not F, and then you have a line, and 3 is blank, and the justification is blank. So this is in 7.1, section 1, and section 1 is the baby steps, right? So what they want to do, would you know what to put here? So they want to see if you can look at 2 premises and see what rule of inference would work. And here it's going to be modus tollens. You remember modus tollens, if P then Q, not Q, therefore not P. And you've got to understand the whole point, I mean not the whole point, but a skill you need. You have to recognize this skeleton. Do you all realize the G is the P, the F is the Q, the not F is the not Q, and you should realize that you could put the not P. The not P is right here, and the not P happens to be not G. So they want to see if you know that you're supposed to put a not G in there, and if they say what right do you have to do that, you're going to tell them I use line 1 and line 2, and I use modus tollens. So section 1 is stuff like that, and that'll be good practice to get you ready for when you derive them with the full examples, which will be in section 3. Now here's exercise 7.1, section 2. I'll give you an example what this is like. Okay, what if you have first premise is either B or K, second premise is blank, and there's a line, and your conclusion is K, and you were to justify it. Here you know what the conclusion is. They want to know if you can figure out what you put in here. What do you need to put in here to get a K? And hopefully you can see that you need a not B. Because as soon as I see a little wedge, right, I know I'm dealing with disjunctive syllogism, and that is either P or Q, and since it at least has to be 1, not P, therefore Q. And hopefully you can see, remember this is all about seeing those P's and Q's. Did any of you see the Da Vinci Code, the movie? You remember when there was a code, the movie makers would make it kind of, they'd bring it out by having it light up a little bit. If some of you haven't seen the movie, that'll make no sense. But here you want to look at this and go, there's the P, this is the Q, this is the not P. Here, let's do this so we don't need this little line. Oh, that's not good. Okay, let me get that back in there. Okay, B or K, and take the little one there. Let's erase that here and do it over here. Okay, this is the P, This here is the Q, not P. This is Q. Okay? So either P or Q right there, not P. Therefore, whatever that is comes down here. So we know to get K, we need a not B. Okay? And actually, I probably should make that black here. Let me just do that. So if you have either B or K, this was blank K, you know we need a not B. Then this cancels these out, you put K, and your justification is I use lines 1 and 2 DS. Okay? So this is how these two examples work. Now what I'm going to do in the next video, this is kind of prep, I'm going to start working on some examples where you're going to do Roman numeral 3, section 3. This is the goal. Okay, so we'll stop here. We'll go to part 2 of this, and these examples are going to help you. Okay, and this video here is to get you kind of prepped for this.